Okay guys, so what we're going to be starting today are the complex fractions, which you've already basically been working with when we've had division, because all of a complex fraction is a fraction on top of a fraction. So we're going to be doing, real quick, the type with just the elementary school example where you have a number, fraction on top. Now, not only are we doing a fraction on top of a fraction, but we're going to do an operation with it. So you can see you have one fraction on the top, whether it's with variables or just a number, and then an addition of two fractions at the bottom. And that's our goal today. So let's just do the one again with just the numbers from elementary school, no variables. The first step you want to do is you want to add and do addition before doing division of the fractions. So let's do 2/5 plus 5/6. And remember, you need a common denominator. So the common denominator there would be 30. So I'm going to multiply this by 5, multiply this by 5, multiply this by 6, multiply this by 6. So I have 12 over 30 plus 25 over 30, which would make 37 over 30. Now, that is not your final answer because now, remember, that was the denominator of this division problem. So you're going to do 1/3 divided by 37 over 30. Or we can write it as 1/3 divided by 37 over 30. If you need that reminder, you're more than welcome to rewrite it like that. If not, no big deal. And then you remember, you change it into a multiplication problem with the reciprocal. And then instead of, because without a calculator, 3 times 37 could be a pain, but remember, you could simplify diagonally. So I'm going to divide by 3 here and make 1, divide by 3 here and make 10. So when I multiply straight across, I get 10 over 37. And that is the process that we're going to be doing, but now in Algebra 2, we're going to be starting to do it with variables. So, turn the page, and we're going to go over different problems. I just have about 3 here, okay, where I can give you an example of how it works with variables. Obviously, it's a little trickier, but totally doable. All right, so let's take a look on the next page. Okay, so I try to list the steps out as much as possible. First thing, just like before, you want to add fractions in the denominator or numerator, wherever the addition sign is. So in that case, that's here. So we're going to do what we've been doing, adding these. So you need a common denominator, which is going to be both of them. So this one I'm going to multiply by x minus 4. This one I'm going to multiply by x plus 1. I don't have to do FOIL or box or anything on the numerator. It's just distributive property. So 1x plus 1 over x plus 1, x minus 4, plus 3x minus 12. Do distributive property correctly. Don't skip a factor. So then together, my new denominator after adding would be, let's see, 4x minus 11 over x plus 1 and x minus 4. Then from there, guys, this is where you want to multiply by the reciprocal. So rewrite the original problem, but now change this as your denominator. I'm going to rewrite that right here, just so that we're familiar with that. So it's 3 over x minus 4 divided by, so this one fraction, divided by the new fraction that we got from that sum of those two. So 4x minus 11 over x plus 1, x minus 4. So then, just like on the front with the numbers here, this fraction bar changes into division, which means we're going to multiply by the reciprocal. So I'm going to really rewrite this as 3 over x minus 4 times x plus 1, x minus 4 over 4x minus 11. Now here, this kind of right away, I guess I didn't need to make this little chart, but from here, dividing out the common denominator is the same thing as crossing off. So this step we can basically do right here and cross off that common factor, which we did there. So remember, that's the same thing as cross off. So I'll just write that at basically, I mean, if you could use both boxes if you want to rewrite it, but it's basically the same thing. And then finally, when we multiply straight across, just make sure you write the simplified form. So you could leave it in factored form, so 3 times x plus 1 over 4x minus 11. Or you can do distributive property, 3x plus 3 over 4x minus 11. Both would be correct. So you can see it is a lot like doing the numbers, but you have to make sure you can add and subtract. Okay? All right, so let's turn the page. Okay? Let's try example 2 here. Now, if you notice, the only difference is here, you don't have an addition problem on the denominator, so let's change this over here. I've switched it up, and let's look at it when it's on the numerator. But the process still doesn't change. You're going to start with adding the fractions in the numerator first. So 1 over x minus 5 plus 1 over x plus 5. So again, common denominator, I'm going to multiply them by each other to help. Distributive property, that makes x plus 5 over the denominator. That makes x minus 5 over the denominator. And then again, you just want to make sure to simplify that. So when I simplify that, really, the two 5s kind of cancel each other out because they would make 0. So then that just becomes 2x. So 2x over x plus 5, x minus 5. So again, now take this new numerator and let's rewrite the original problem with this fraction as one single fraction instead of the 2 at the top. So it's going to be 2x over x plus 5, x minus 5, divided by 1 over x plus 5 squared. But I don't like that being written like this, guys. Instead, let's write it twice, because if you square something, you multiply it by itself. So we're going to write it as x plus 5 and x plus 5. So now we're going to just multiply by the reciprocal. So times x plus 5, x plus 5 over 1. And then like I said, basically dividing out the common denominator is the same thing as simplifying. So let's just cross off. And that's it. You cannot cross off all 3. Remember, they only come in pairs. So in this case, when we multiply across, we get 2x times x plus 5 over x minus 5. So that is perfectly fine, okay? Sometimes people, again, simplified form, you could have also did distributive property. I like to leave it in factored form personally, so this would be fine. But if you prefer to use distributive property, then you could have that as your final answer. But both of these are completely fine. All right? So you can see, guys, it is a good amount of work, but it is definitely doable. You just have to take your time when it comes to adding and subtracting the fractions. So the last one is a little trickier, okay? The last example I have for you, it's because you have to add and subtract both the numerator and the denominator. You want to get a single fraction. So let's turn the page here for the last example, and then you'll get plenty of time, a good like 25, 30 minutes to practice these 6, okay? Because they do take time, but they're totally doable. This one's going to take more time because not only am I adding fractions in the denominator to make a single fraction, I'm doing it to the numerator. Okay? So keep that in the back of your mind. So this one's going to be a little bit trickier. So let's do the numerator first. Our goal, again, is to make this into a single fraction. I'll do that above here so we can just kind of make room since it's a bigger one. So 5 over x minus 2 minus 2 over x plus 2. Again, same thing we've been doing, common denominator, so multiply by x minus 2. This one I'll multiply by x plus 2. Do the distributive property. Make sure you do that correctly. So this would be 5x plus 10. And then you have your denominator. If you don't want to keep writing the denominator, it's not the end of the world. I know it's a little tedious. Common denominator. Do distributive property. So one fraction that comes out of this, okay, the one fraction that comes out of this, 5x minus 2x is 3x. 10 minus negative 4, be careful about double negatives, is going to be plus 14 over that denominator, or the denominator that we have. So this is my new numerator. I've made one fraction from the subtraction problem. It started with 2. Now here's my new numerator. That's going to be the when I'm setting up to change it to division. So put that there. So again, that is my new numerator. Now I'm going to do the same thing, but with the denominator. Okay, and I'll just do that right here. But for this one, you're going to have to factor. Okay, so I'm going to take the 7, and I'm going to factor this as a difference of squares. So x plus 2, x minus 2, subtracting. Now the nice thing about this though, guys, if you look, you don't have to multiply both fractions. Okay, they already have in common x plus 2, so all you have to do is multiply the fraction on the right by x minus 2. You still have to do your distributive property correctly in the rest of the math, but it's nice that you don't have to multiply both of them like we had to for the numerator. So I'm going to do distributive property here. So now let's see if we can combine like terms. Now be very careful about this because look, 7 minus negative 10 is not 3 and not negative 3. 7 minus negative 10 is 17. Okay? So I know it's going to be 17. And you notice there's not an x here on this fraction, guys, but you have to imagine that there was a 0x placed because the 5 is being subtracted from nothing, and in math, nothing is 0. So 0x minus 5x makes that negative 5x over the denominator. So let's rewrite that. That's my new denominator now. Okay, this whole fraction is going to be my new denominator in my problem. So you're basically rewriting now the division problem itself. So now we have one fraction on top of another in a division problem. That's your goal. You want to add and subtract first to complete that task. One fraction on top of one fraction. Now we can multiply by the reciprocal. So 3x plus 14, which I can't factor that, so I'll just leave it like that. X plus 2, x minus 2, times, flip this, x plus 2, x minus 2, over 17 minus 5x. Then, dividing out any common denominator to get your answer, guys, is the same thing as crossing off the common factors. So when we multiply straight across, remember there's a 1 left here and a 1 here, not 0. You actually get 3x plus 14 over 17 minus 5x. There's nothing to factor here in the final answer, so this would be considered the simplified form. If you really wanted, you could switch to have the x first, make it negative 5x plus 17, but it doesn't really matter. Both of those are completely fine. So it is a good chunk of work, guys, but you can do it. You just have to use your knowledge of the multiplying, dividing, and the adding and subtracting. That's why we spent so much time, especially on adding and subtracting, to make sure that you can do it. So if you notice here, it is 6 problems for classwork today. We're going to give you about 25-30 minutes, okay? Then I'll give you the answers to it, but you got to show all your work. Don't take these lightly. Don't try to skip steps. Just take it piece by piece. Follow the steps that we did. We're going to review this more on Tuesday when I'm in class, but you want to take this seriously because we don't have a lot of time to be reviewing it. We're going to be moving on to our last 2 topics for the year. So take about 25, 30 minutes to go through these 6 problems, see how well you do on it, and then you'll be given the answers so you can check and see how well you did. Good luck.